Okay, welcome back again. Here is question 5 to 10 on the objective part of 2023 NECO Physics past question. So we have solved question 1, 2, 3 to 5. So question 6 says, so question 6 says, question 6 says, a body starts from rest and moves with a uniform acceleration A until it attains a velocity V. The expression for the time taken to attain this velocity in terms of the given parameters is, so you have option A to be A over V, option B 2A over V squared, option C V all over A, option D V over 2A, and E V squared over 2A. So let's get it done and see the correct option here. So question 6, whenever a body is said to start from rest, your initial velocity U is equal to 0. Take note of that, right? That is the first step. So it accelerates uniformly with acceleration U. We are given that acceleration A rather, given that acceleration is equal to A, right? Until it attains a velocity V. So final velocity is said to be V. So we're looking for the expression, and this take place at time t, right? Time is equal to t. So remember our famous formula, which is acceleration. Acceleration is the change in velocity all over time, which is equal to final velocity minus initial velocity all over time taken, all over time. So we are given that acceleration is A, we write it, is equal to final velocity is V minus initial velocity, which is U, but is equal to 0 because the body starts from rest. So here is 0 all over time taken, which is T. So we're looking for the expression for the time, right? That's what we're looking for, expression for the time. That is, you're making T subject of the formula. That's all what it means. So here now, we're going to have A equal to V minus 0 is V all over T. So from here, cross multiply, making T subject of the formula, we have A multiplied by T is equal to 1 multiplied by V is V, which implies divide both sides by A, T will be equal to V all over A. So that is option C, V all over A. I hope this is understood. So question 7 says, a force of 150 Newton is applied perpendicularly to the end of a 30 centimeter spanner to remove a knot. Calculate the moment of the force. So we are given that force, force F is equal to 150 Newton, and the length of the spanner, which will serve as the distance, perpendicular distance, D. So distance, D, is equal to 30 centimeter. Except otherwise stated, always convert to meter. So we have 30 centimeter, convert it to meter, that will be 30 divided by 100, which will be equal to 0.3 meter. So the next thing, we are asked to calculate the moment, right? Moment, that's what we're looking for. So moment of a force is the turning effect of that force. So moment is nothing but what? Force multiplied by the perpendicular distance. So that will be equal to 150 multiplied by the distance, which is 0.3. That will give us what? 150 multiplied by 0.3. That will give us 45 Newton meters. I hope this is understood. So option A, 5 Newton meter. Option B, 45 Newton meter. Option C, 50. Option D, 450. Option C, 4,500 Newton meter. So I hope this is understood. Don't forget the formula for moment, because this question can be turned, maybe you'll be asked to find force or you'll be asked to find D, as the case may be. So let's quickly move to question 8. So question 8 says, an example of a body in a stable equilibrium is, so a body is said to be in a stable equilibrium when slightly displaced and return to its original position. So you can say the body is in a stable equilibrium. So let's look at the option here. Option A says a ball resting on a vertical, on an inverted balls. So let's say we have balls like this that is inverted. So, and you have a ball here. Can we say this ball is stable? What if I displace it in this direction? Will it come back to this position? No. Therefore, it's wrong. Option B, a cone resting on its base. You have a cone like this, like a funnel, right? It's resting on this base. Can we say it's in equilibrium? Yes, because if you displace it in this direction, right, it will return to its original position. So here is in a stable equilibrium. Well, this is our answer. Let's still look at the rest in case if they turn this question in another way. So the next one says, a cylinder resting on its side. We have a cylinder like a drum. So we have a cylinder like a drum. If this drum is resting on its side like this, what will happen? What if I roll it like this in this direction? Will it come back? No, it will tend to move further away from the original position. Therefore, it's not in a stable equilibrium. Let's look at option D, egg resting on its apex. We have an egg that is resting on its apex, something like this. I might not get it. You know, eggs, isn't it? Assuming it's resting on this. Can we say it's stable? No, because if I displace it in this direction, it will not return. The last one is a sphere on a smooth horizontal uh, table. Also, it's not stable. We have a sphere on a smooth horizontal table. If I displace this sphere like this, in this direction, it will not come. So our correct option here is option B, a cone resting on its base. I hope this is understood. So let's quickly move to question 9. So question 9 says, a ball kicked at an angle 40 degrees to the horizontal hit the ground 3 seconds later. Calculate the initial velocity of the ball, neglecting air resistance, and take G to be 10 meters per second squared. This is under projectile. So this is what you do. So the ball is projected, right, at an angle 40 degrees to the horizontal, and here is u, the initial velocity. So, and it comes to the ground, it hit the ground 3 seconds later. So it means that the total time spent in air is 3 seconds. That is the time it takes to get to the maximum height and the time it return to the what from the height, or it hit the ground. The time it hit the ground, right? That will give us what is known as time of flight. So in this case, it shows that time of flight t is equal to 3 seconds. So, and u is what we are looking for, the initial velocity. And the theta is equal to 40 degree. And we were told to take g as 10 meter per second squared. So the next thing is to recall the relationship between time of flight, initial velocity, and the theta and that of acceleration due to gravity. Remember, we have time of flight, capital letter T, is equal to 2u sine theta all over g. Is that correct? So then the next thing is for us to substitute the value. So what is T? T is 3 equal to u multiplied by 2 multiplied by u sine 40 degree. Everything divided by 10. So the next thing is for us to find the value of sine theta, sine 40. So we're going to have 3 is equal to 2 multiplied by u, then multiplied by the value of sine 40 degree is 0. 427. So 0.6427. Everything divided by 10. So here we have 3 is equal to, multiply 2 by 0.6427. That will give us 1.285. So 1.285 multiplied by u all over 10. All over 10. So let's complete the rest here. So the next thing is for us to cross multiply. 1 multiplied by this, that will give us 1.285u is equal to 30. This implies u is equal to 30 divided by 1.285. So press your calculator, 30 divided by 1.285. That should give us 23.3 meter per second. Is this understood? That is option C, 23.3 meter per second. Okay, let's quickly add question 10 before we call it a day. So question 10 says, a body vibrates with simple harmonic motion at a frequency of 100 Hz. If the amplitude of vibration is 5 centimeter, calculate its linear speed, given that pi is 3.14. So question 10, we are given that frequency f is equal to 100 Hz. and the amplitude A is equal to 5 centimeter. I told you, except otherwise stated, always convert from centimeter to meter. To do that, we say 5 divided by 100, which will give us 0.5 meter. So when that is done, we are asked to calculate linear velocity. Linear velocity. So which is V. That's what we are looking for. So now you have to recall the relationship between linear velocity and angular velocity. Remember that linear velocity is equal to omega A, the angular velocity multiplied by the amplitude. Now, in this case, in the whole of this question, there is nowhere they give us the angular velocity. So what do we need to do? So we now recall that there's a relationship between the angular velocity and frequency. We have angular velocity omega is equal to 2 pi f. So that's what we're going to use to get our angular velocity. This will be equal to 2 multiplied by pi is said to be 3.14 multiplied by 100, the value of hertz of the frequency. So that will give us, when we multiply them together, it should give us 628.4 rad per second. So when you're done with this, come back to this formula, V equal to omega A. Now we have our omega, which is 628.4 multiplied by the amplitude, which is 0.5. So press your calculator. That should give us 31.42. 31.42 meter per second. So that is option C, 31.4 meter per second. I hope this is well understood. So we are going to stop here in question number 10 and continue from here in our next class. Please, if you are new to this channel, I plead with you to subscribe to my channel to give me some visibility. Thank you. God bless you. And don't forget to share to benefit others.